Welcome to qnawire.
So this is the figure given in the textbook. Here, this support creates a reaction Gy. So let's draw this. Because of this support, there will be a reaction. Let's name it Gy. Okay, yeah. And because of this, there will be a reaction. Let's name it By. And this creates a reaction. Let's name it Bz. Bz. Okay, and here this is a pin support, so there will be reaction along X, Y, and Z axis. So the reaction along Z axis is named as AZ, AZ, and the Y is named as AY, and the X is named as AX. Okay, yeah, the distance is given in feet. So let's move to the problem. So for a space truss to be a simple truss, it starts with a tetrahedron truss and any added three members attaching three existing joints with a new joint. So in the free body diagram shown in this figure, let's start with tetrahedron BEFG. So let's start with BEFG. So I repeat, for a space truss to be a simple truss, it starts with a tetrahedron truss and any added three members attaching three existing joints with a new joint. Okay, yeah. So let's start with BEFG. Here, first the added members B, D, and ED and GD attaching three existing joints B, E, and G with new joint with new joint D. Okay, now the next one will be the added members B, C, and DC and GC attaching three existing joints B, D, and G with the new joint C. Okay, the next will be the added members DH and EH and GH attaching three existing joints D, E, and G with new joint H. Okay, the last will be the fourth one will be the added members BA, and EA attaching three existing joints BED, BE, and D with new joint A. New joint A. So therefore here the truss is a simple truss, like therefore truss is a simple truss. So if the truss is completely constrained from the free body diagram shown in here, we have 6 unknown reactions: AX, AY, the AX, AY, AZ, AZ, then BY and BZ, BZ, and the GY. So we can determine the 6 unknown reactions by applying equilibrium of momentum about member AB and joint G. Therefore, truss is completely constrained and its reaction are statistically determinate. So first, yeah. So first, to determine the force of the 6 members joined at E, we need first to determine the reactions of the entire truss. So forces in vectors. So the FH will be then 275 lb along I, okay, minus the 240 lb along K, okay, and then we can find the FG. Vector Fg will be equal to minus of Gy along J, and we can find the vector Fb will be equal to the By times, so By along J minus Bz along K, okay. Now then the vector Fa, let's find Fa also. Fa will be AX along I plus the Ay along J minus the AZ along K, okay. Now the summation of F equal to 0. So now let's draw the diagram first. So we already, yeah, so for joint A, yeah, let's find the components. Okay, yeah, the component at A direction. To find the component at I direction, we have to find summation along x equal to 0. That gives you 275 lb, 275 lb plus AX equal to 0. So here, from here, therefore AX will be equal to minus of 275 lb, okay, and component at J direction. So to find the component at J direction, you need to find summation along y equal to 0. That gives you AY plus BY minus gy equal to 0. Then the component at k direction. So the component at k direction means the summation along z direction equal to 0. That gives you that 240 lb minus az minus bz equal to 0. Okay, now we got two equations. Let's move to the let's find momentum of AB equal to 0. So this gives you sorry 9.6 feet times gy minus 10.08 feet times 240 lb equal to 0. So here the unknown is gy. So the value of gy will be 252 lb. Okay. Yeah. Now summation along summation of momentum of AD equal to 0. So the 11 feet into By minus the 11 feet into Gy minus 10.08 feet into the 2750 lb. Okay, 2750 lb equal to 0. So from here we got the value of Gy. Substitute the value of Gy in this equation. That gives you the value for By. So By will be 504 lb. Okay, so substitute By and Gy in equation 1. Like in this equation, let's name it as yeah. Let's name it as equation number 1, and let's name this one as equation number 2. Okay, so substitute the value of By and Gy in this equation. That gives you the value for Ay. That will be so the value for Ay will be minus of 252 lb. Okay, and now let's find summation of momentum at Cg equal to 0. So 11 feet into By minus 11 feet into Az minus 9.6 feet into Ax equal to 0. So we know the value of Ax and By. Substitute that values here. That gives you the value for Az. That will be 0. And substitute the value of Az. Substitute the value of Az in the equation number 2. That gives you the value for Bz. So the Bz will be minus of 240 lb. Okay, we got the Bz also. So after determination of the reactions, use join method to get the forces at members joined at E. So let's start from the joint A. Yeah, so for joint A, let's draw the diagram first. So if this is joint A, there will be F AB, F AD, FAE AX and AY. Okay, let's denote the axis. So this will be X axis and this will be the Y axis and this will be the Z or Z axis. So here summation along y equal to 0 gives you F A E plus AY equal to 0. So from here we already know the value of AY. Substitute the value of AY in this equation gives you the FAY. FAE will be 252 lb, and you can see in the figure FAE is going outward. Okay, so that creates tension. Let's denote it by the letter T. Yeah, now let's move to the next joint. Let's take joint H. Yeah, joint H. So for joint H, if this is joint H, there will be a 275 lb, and this is around I component. Okay, and let's directly give the values. There will be 240 lb, and this is around K, and this will be FHG, and this will be the FHD, and this one here, this will be FHE. Okay, this is FHG. Yeah, and let's draw the axis. Yeah, this is my axis. This is X axis, and here this one is Z or Z axis. So yeah, so summation along, let's use black itself, right? Yeah, summation along H. Let's just find summation of Z. Okay, so summation along Z equal to 0 gives you FHE minus of the 240 lb is 240 lb equal to 0. So FHE, we will directly get the value of FHE, that is also will be 240 lb, and you can see here the FHE, the direction of FHE. Yeah, actually the FHE is going outward from the point H, so that creates tension. Let's denote it by the letter T. Okay, yeah, yeah, and the summation along y equal to 0, that gives you directly the value for FHD, that will be 0. along Y, the only thing is FHD, so that will be 0. Yeah. Now let's move to the next joint, that is joint D. Here there is one thing we should remember, that is the FHE, like that. The actual direction of FHE, you can see here, the actual direction will be going inward. That's why FHE minus 240 will be. So if it's going inward, so that means the FHE is going inward, that creates compression. Let's denote it by the letter C. Okay, sorry for the confusion. Yeah. Now the next joint, that is joint D. Let's draw the diagram first. So for joint D, if this is joint D, this will be FDC, this will be FDG, and this will be FDH, this one FDE, and the FAD. Okay, now let's draw the axis. This is x-axis, this is y-axis, and this one here, this is z or z-axis. So summation along x equal to 0 gives you the FDG equal to 0, and summation along y equal to 0 gives you FED equal to 0. Now let's go to the next joint, that is joint E. So let's take that here. So for joint E, let's draw the diagram first. Consider this is joint E. So there will be a force FED and the FEH just next to it, FEG, then FEF, FEB, and last FEA. Okay, let's draw the axis. This will be x-axis. Here there will be y-axis, and this one will be z or c-axis. Okay, and also we know the distances here, that is this one, this is 9.6, this is 11, so the hypotenuse will be 14.6. okay, and here also we know this one here, this is 10.08, okay, 10.08, and this one is 11, so the hypotenuse will be 14.92. Yeah. Now let's solve this. Summation along Z over C. Let's start with Z over C equal to 0 gives you F H E minus the 9.6 divided by hypotenuse 14.6 times FEG equal to 0. We already know the value of FHE, substitute that value here. That gives you the value for FEG, that will be 365 lb. Okay, and you can see here the FEG is going outward from the point E. That creates tension. Let's denote it by the letter T. Now, yeah, summation along y equal to 0 gives you minus of FAE, again minus of the 10.08 divided by the 14.92 times FEB, okay, equal to 0. So from here substitute the value of FAE in this equation. That gives you the value for FEB, that will be minus of 373 lb. The direction of FEB, you can see here, is going out, but there is a negative sign in the solution. That means the actual direction of FEB is actually going inward. That creates compression. Let's denote it by the letter C. Okay, yeah. Now summation along X equal to 0 gives you FE F plus the 11 by 14.92 times FEB plus the 11 by 14.6 times the FEG equal to 0. We calculated value of FEG and FEB. Substitute that values in this equation. That gives you the value for FEF, and that will be actually 0. Yeah. So I hope you understood the problem. Thank you.